Bob is going to be talking to us about national trends, about global trends, about weather patterns that are happening at a scale much beyond our little valley here. Robert Sandford is really a remarkable figure in the world of Canadian water. He is really filling a role that no one else is filling, being able to go out and communicate to people about climate issues that maybe are a little too controversial for government employees to talk about, but it's something that everyone really needs to know. This is the kind of at the state of the science for what we understand is happening with climate. He's going around talking to people at universities, with government agencies. He's done some amazing trips to the Middle East, talking with people internationally about the patterns that they're seeing. And he brings it all together, and as a speaker and as a writer and as a mentor, he is really contributing an amazing amount to those of us who are working in the water field. So I always am incredibly grateful for knowing Bob and for being able to attend his presentations whenever I can. So thank you for coming, and I'd like to welcome you up here.
I'd like to thank Anna for a kind introduction. I should also say that in my estimation, the Okanagan Basin Water Board is one of the very best organizations of its kind in North America, and you're very lucky to have it. And I would like also to thank Zoe and others for the opportunity to speak to what I consider to be an expert audience, a very distinguished and wide-ranging group of water management professionals. And I notice how multidisciplinary and multi-sectorial this group is, and I think it's through this type of collaboration that we'll be able to address these kinds of problems. As Scott has pointed out, you live in a highly dynamic landscape that could very well be at the tipping point of greater vulnerability. So I've been invited today to talk about what we can learn from science and from recent events that will help us enhance community resilience to accelerating hydroclimatic change in Canada. So as many of you here will know, if you were here in 2003, that hydroclimatic change is no longer an abstract idea or a theoretical concept if what you're studying comes after you or threatens your life or livelihood. And because it's so topical, and because it affected me, my family, and many of my friends and neighbors so very personally, I'd like to explain what is happening to the hydrological cycle in Canada by way of the recent disastrous flooding that took place in Canmore, where I live, and downstream in Calgary and in surrounding communities in southern Alberta in June of this year. As some of you here will know, we already had a pretty good understanding of the effect increasing atmospheric temperatures were having on the global hydrologic cycle long before the big floods in Alberta in 2013. Hydrologists, not just in Canada but worldwide, have been reporting changes in the rate and manner in which water moves through the global hydrologic cycle for at least a decade. And it's probably safe to say, though, that very few of even the most far-seeing researchers were able to recognize just how serious these consequences might be. And I think it's fair to say that all you have to do is open the newspaper or turn on the news, and it becomes clear that changes in the manner in which the global hydrologic cycle functions are beginning to test the resilience of our economic systems, the adaptability of business, and the flexibility of governments around the world. There remains, however, a huge gap between awareness of these problems and the amount of policy attention that they receive. Each year, the World Economic Forum evaluates the threats posed by 50 global economic, environmental, geopolitical, societal, and technological risks of concern in the immediate and long term. And in 2012, the World Economic Forum ranked water-related issues fifth in terms of their likelihood of slowing economic performance globally. In 2013, global hydroclimatic crises were ranked fourth among threats generally, but second in terms of their potential to impact not just the performance, but the very survival of businesses in many sectors of the global economy. So what we're seeing is that hydroclimatic change is colliding head-on with an already troubled economic status quo. So please allow me to introduce some of the telekinetically connected hydroclimatic effects that have been identified as threats to the global economy. So I'll first explain the link that appears to exist between how much sea ice and snow cover there is in the Arctic and the effect of diminished cold on the intensity and stability of the band of winds that circulate around the northern hemisphere that we call the Jetstream. I will then demonstrate the link between a meandering jet stream and the movement of warm and cold fronts into places into which they don't often go and don't normally stay. And this may be of particularly concern to you, and certainly all of us living in the Canadian West, because it's this emerging pattern that appears to be causing heat waves and droughts to persist far longer and to occur more widely. I will then introduce a very simple principle of atmospheric physics that explains how a warmer atmosphere can transport more water vapor and how this simple fact results in the potential for heavier rainfalls. And finally, I hope to demonstrate how all these factors together are creating more frequent and more intense flooding events. And I'll link these factors to the recent flooding that we've witnessed, not just in Alberta, Saskatchewan, and Manitoba, but widely in Canada and throughout the rest of the Northern Hemisphere in the last decade. And I will then discuss possible consequences and implications for public policy here in the Canadian West. And from this, you may be able to derive a sense of what it means, all of this might mean to you here in the Okanagan. So to begin, one of the most significant recent advancements in hydrometeorology is the realization of the global importance of the refrigerating influence of polar sea ice. Three factors related to the extent and duration of Arctic sea ice have emerged as having great significance to the lives of every person on this planet. The first is the amount of heat required to melt sea ice. The second is the potential effect of sea ice melt on ocean acidification and on the reliability of deep ocean currents. The third is the profound influence of Arctic cold on the stability of weather conditions further south and globally. Water, as many of you will note, because I noticed there's a how hydrated you are graph in the washroom. I gotta figure you guys are really into this water thing. So water is, as many of you know, is an almost otherworldly substance. Once it's frozen, it takes an enormous amount of heat to weaken the hydrogen bonds that hold water molecules in the lockstep crystalline structure of ice. The amount of energy required to melt 1 kilogram of ice that's already at 0 degrees Celsius is equivalent to the amount of energy required to raise the temperature of 1 kilogram of liquid water 79 degrees. From this, we can see why ice and snow are such powerful climatic refrigerants. But the strange thing is that you have to put all the heat in before any change whatsoever occurs within that crystalline structure. It's only when ice reaches 0 degrees Celsius that it melts. And from this, we can see the power of the refrigeration. The problem, however, is that the moment after solid ice collapses into liquid water, all the heat you add afterwards will suddenly make temperatures rise, thereby increasing evaporation. And polar ice is now seen as a thermostat that governs major weather patterns globally. And it's now feared that the decrease in the extent and thickness of sea ice could be the parameter that's feeding all of the increases that are causing concerns over climate change. And while it appears that it will be less this year, the area of Arctic ice that melted last summer was 2 million square kilometers larger than the entire area of Canada as a landmass. Sea ice is a thermal helmet without which climate warming can give the Earth system a shot straight to the head. So if we lose the refrigerating influence of Arctic ice, global temperatures could skyrocket with possible releases of methane in the permafrost zone that will further exacerbate warming. And as I'll demonstrate later in the presentation, recent evidence from Siberia suggests that this may already be happening. In addition to the thinning and reduction in the extent and duration of sea ice cover in the Arctic, extreme events in the form of Arctic cyclones are breaking up the ice, further accelerating melt. I just always like to show this picture because I think physically and figuratively the result resembles a frozen hurricane. It's this difference in temperatures between the polar region and the warmer air to the south that largely defines the behavior of the jet stream. Observations of the jet stream have revealed that warmer atmospheric temperatures do not automatically translate into warmer weather. In a uniformly warmer and therefore more turbulent atmosphere, both warm and cold fronts end up and persisted in places in the mid-latitudes in which they were not common in the past. And what we're also seeing is that changes in atmospheric circulation patterns are pushing major subtropical storm tracks toward the poles, causing floods of magnitudes that we're poorly equipped to manage. And this is also why we're seeing, more and more widely, droughts and wildfires followed by major floods in the same basins in the same year. And that's why I call this common hell and high water, because you're really getting both in some basins in the same seasons. So what we're seeing is not uniform warming, but destabilization of historic weather patterns. And people all over the world are complaining about this. They're saying that the weather's all over the place. Well, it is all over the place. And 2 years before the great floods in Canada in 2013, we already knew why such extremes of weather appeared to be becoming more frequent. Recent research has clearly demonstrated that in the Arctic and through much of the Canadian boreal, water that has been trapped as sea ice, in glaciers, and as permanent snowpack and permafrost is in rapid decline. And in 2011, we organized a national speaking tour to communicate these findings and to profile the Northwest Territories' new water stewardship strategy, which we considered to be exemplary and worthy of the attention of southern jurisdictions. And one of our first stops, surprisingly, was Winnipeg, where we arrived just after one of the largest floods in Canadian history. And it appeared at the time that the Great Plains were approaching, or perhaps had even passed over an invisible threshold into a new hydroclimatic state to which many residents had been unable to cope with, let alone adapt. And concern was being expressed that the loss of hydrologic stationarity could make parts of the central Great Plains region uninhabitable, and just as importantly, that ongoing flooding could, over time, bankrupt affected jurisdictions. But it was also what the floodwaters carried that concerns us.